Yeah, hello class. Yeah, we are back into our topic 7. I hope all is well. People feel very fine and fresh. Not so? Yes. Yeah, people talk long to answer that, meaning we can find out. Patience, are you very fresh? Grace, you are fresh? Okay, to check that, as usual, we will just check that brain only. You might not stand and shout, but let your brain reason out. Listen to this question, and we will recognize you very much if you happen to answer it. Are you listening?
Yes, sir.
A plane was from London coming to Uganda, and some many years back it crashed between the border of Uganda and Kenya. Where were the survivors buried? In which country? No, you want somebody who is very sure of the answer. Let me repeat the question. Let me repeat the question very well. Don't communicate to your friend. You want to be attentive. A plane was from London to Uganda, and it crashed between the border of Kenya and Uganda. Where were the survivors, in which country were the survivors buried? Let me start with, as the group goes, with the Precious.
Survivors, first of all, are people. Like if it's an accident, obviously they have not died. They have survived from the accident, they haven't died. So they weren't buried because
That's very wonderful. That means the survivors weren't buried anywhere. Thank you very much for being very attentive. The survivors don't die. Okay. Now, 2. I want to give you a logic. Have this calculator. People should enjoy their math, not so? Now I will ask you to mention for me 4-digit numbers. I will write the answer before even you give me the answer. Give me any 4-digit number of your choice.
867.
867. The 4th digit.
2.
2.
888.
You wanted the. Now me I'm giving. Let's follow order, not so? You have given 8672. Let me write the answer before even I continue with the question also. You are ready? I'm putting the answer. The answer is there. We are doing magic, not so?
The answer.
Now listen, we are going on. Now, let me remove this first. Give me another 4-digit number. We are going to add them. Quadruple 8, like this.
Yes.
Let me first put the answer we are going to add. Yes? The answer was 28670. Now, let me also write first. For you, I've given you 2 chances. Let me also write. Not so?
Yeah.
1111. Give me another 4-digit number. Yes.
3984.
3984. Let me also write. Then we add. The answer is already there. I give mine. Okay. Now add and we see. You have put the answer already. I've already added. What do you get? What do you get?
28,670.
70? 70.
Oh, good 76.
Is it the same answer that I've put there?
She got wrong with how she wrote 5 instead of 2.
Let me give you another chance. Maybe you are doubting the magic, not so? Mention any 4-digit number again. Let us start. Now, since you are 3, I will only expect the first to give. Each one has one chance, okay? Who starts? Yes? 2007. Not so? And somebody else mentioned, maybe you might think I'm guessing. Yes, Precious. 19. Let me also mention before she mentions, not so?
Getting the very same answer.
Wait. I mentioned mine first. Okay. But I mentioned mine. Okay. Now, let me put the answer before. Are you together? The answer that we shall get after adding will be this one. Is it correct in mine? Yes, I've added well. Now, it is your chance. Who did mention? Yes, mention.
987.
987. She's mentioning the hard one so that it fails. Let me put mine, I'm the last. Now, I put mine, eh?
Yes.
Okay. I make sure. Okay. I put mine, you're sure? Okay.
Yes.
Now, add.
Yeah, that's the one.
Is that-
22?
That the answer?
22,005.
Yeah.
You. For me, I think it's not black magic. But I think you first wait for us to tell the numbers, then you calculate in your mind,
No.
and then write the last number.
No. Let me do. You are doubting.
Yeah.
I will only ask
Yeah,
you.
you
No.
be the first to write yours.
To write.
Also.
Then for you, write.
Then we also tell ours.
Or I give you a chance and you also mention the answer before. Now you'll have that one as your brain check in your time. You check your heads, how does the answer come about? That right? It's black magic. Let us go to our topic 7. Now that means next, when I meet you again in topic 8, I'll tell you the money you have kept in the dormitory before you tell me. Let us go to topic 7. Topic 7, it's bearing. Yeah. Yes, now we go topic 7. No, we are not magicians class. Now in topic 7, we are going to look at bearings. Bearings, remember we first did the construction. Now today we are looking at bearing. Now in bearing, it's quite a bit slightly long, but we are going to visit, under bearing we shall visit the compass and direction. Compass and its directions. Then we shall also see angles and turns. Angles and turns. Then we shall see bearing and its notation. Bearing and its notation. Yeah. Then we shall visit lastly bearing to scale drawing, bearings to scale drawing, to scale drawing. Yeah. Let us speak on with the compass direction, compass and the direction, compass and the direction. From our primary, we know what the use of the compass. The compass is basically to show direction. And how many major directions does it show? 4 directions. That means it shows, which directions does it show? North and west, north, south, east and west, on the west. Now the north is here, not so? Is that was that the north?
Yes.
The right hand side would be
East.
Then this side
West.
would be the west. Down? South. Now let me ask you, in regard to our country here, where is our north? Like if I'm standing in here, where is our north? North is? You think north is this way? Where does the sun set?
That side.
In the morning the sun comes from and sets where? Now there you are. The north is a perpendicular. The north-south is perpendicular to east-west. If the sun comes from this way, in your geography, in your SST of primary, which direction does the sun come from? East. That means if this is east, then the other side is west. Then where is north? There you are. This will be north, then south. Yeah, that means when the pilots are reading direction, you see that they will now have to follow an actual compass, not so? Now we can as well go on dividing this again. If we divided the north, couldn't we create another direction there? Which direction is here? North, east. This way? Southwest. Then we can divide. What is the angle between north, east and east? 45. Because you've bisected 90. Then this one is, this is northwest. Then this southeast. Oh, then those are the angles. Now, can't we divide any further? What do we create here? North, east. And what? South, west. Even here the same. That one would develop for us. North, west, and south, east. Okay, what if you entered here? What is the angle there? Here would be?
Northeast.
Which is which?
East, northeast.
East, north what? East. East, north. East. Then this one would be west, south, west. Clear? That's very clear. It means you can divide and divide.
West, northwest.
West, north, west. What is this angle here? East, south, east. That is around 20.5 because you divided 45. Huh? It's 90, divide, you get 45, divide 22.5. Okay, that's exactly, that's right. Now, that means we have looked at the first demonstration of a compass and its direction. And you have known that between here, you know various angles that are embedded there. Yeah, that throws us right away to the angles and the turns. Angles and turns. Okay, angles and turns. Now, if you were seated in front and your friend called you from behind, you would turn your head, not so? To copy from your friend, which angle do you turn the head through? Like if your friend was seated on this right, you turn through 90. Now, look here. You can turn through even 60.
Your eyes.
The head or the eyes?
The head.
The head can turn through
60.
or through northeast. Now you see angles run from 0 to 360. Is that very right?
Yes.
Yeah. This is our starting point. Clear?
Yes.
Now if you turn it through 90, because a turn can be either clockwise, you can turn your head clockwise or anti-clockwise. That means that's a very big point. Turn about a point is either clockwise or anti-clockwise. Now, if you turn through 90, how do we call that turn in fraction form? Yes? A quarter turn. That means you'll have turned a quarter way. Yes? Now we have seen that turns can be clockwise or what? Or anti-clockwise. Then examples of those turns and angles. Yes, you mentioned for me some, the angle and that turn. There do you call that turn through which the head will turn about an axis. The first angle is 90. What turn is that? That's a quarter turn. Then the next, if you turn this through 180, half turn, that 180 is half turn. There you are, half turn, quarter turn. See that quarter, a half turn. Which angle would be here? Which angle? 200? You are adding 90. Which turn is that? 3/4 turn. That's exactly. If you come back here, full turn. Yes, 360 is a full turn. You have come back to 0. 360, full turn or a circular turn. Full turn or circular turn. Yeah. Those are some of the turns that we have, notice so? Yeah. Now, those are some of the turns. Now I will give you a sample questions. If now I can bring in a compass here, the compass direction. Now we talk about turns in terms of this. You see, like if we said if somebody turned from northeast through 90 degrees, which direction would that be? See? Okay, that means I'm looking at the compass and the turns. Compass and turns. Compass and turns. Yeah. I will not put many points there. I will only put the major. North, northeast, east. Don't forget the arrows. Southeast, south, southeast. Then this is northwest, west, south, west. Now, compass direction and the turn. If somebody turn is from northeast through, turns northeast through through 90 degrees, which direction will they be?
Southeast.
Turns turns from northeast through 90 degrees. Which angle is that? Which compass direction will they arrive at?
Southeast.
That means somebody would arrive at southeast. Southeast. If you turn from northwest, this is northeast through 90 degrees, and that turn we are taking it to be what? Clockwise. This sense here. What of northwest anti-clockwise? Northwest anti-clockwise through anti-clockwise through 180 degrees.
Southeast.
Where will they arrive?
Southeast.
Southeast.
Yes.
Are you sure?
Yes.
Northwest. That means how have you added? You are adding this from here. How have you? This is 45 plus 45 plus 45. That is southeast, not so? Okay. Now you are waiting to answer these questions here. Southeast. If you turn northwest anti-clockwise, you arrive at southeast. Now, I want you to, are you ready to answer now? We are still on angles and the turn. Angles and the turn. Yeah. And then you can answer this first question here. In what direction? That's question one. In what direction will you be facing if you turn part A? If you turn part A, 135 degrees anti-clockwise from north. 135 degrees anti-clockwise from north. Let us look at part B first. 180 degrees clockwise from southeast. That's enough. How do we arrive at that? Before you got number 3. The question is saying you are from where? In which direction will you be facing part A when you turn from?
From north.
From north, which
135
35 degrees
anti-clockwise.
anti-clockwise. Let me see, where do we arrive?
Southwest.
Southwest. Where have you started to locate?
North.
You located the
Clockwise.
anti this way like that.
Yes.
This is anti, because the clock goes like this. Now, how have you counted? 45.
90 plus 45. I got 100.
This one you reached here, then you added here.
Yes.
That is, you will be facing south, southwest. Yeah. Okay, help us with that part B.
Northwest. Yeah. Northeast.
How are you turning? Turn from
And from southeast clockwise
100
degrees.
clockwise. How did you turn?
We started from southeast
Southeast, you went how? This or that way?
clockwise.
Clockwise like that. And the 45, that gives 90,
135.
135,
180.
180. That means you you face north, west. Answer number 3. Number 3 here says this. The sails of a windmill, sails, S-A-I-L, sails. The sails of a windmill complete one full turn every 40 seconds. Complete one full turn every 40 seconds. Part A. How long does it take to sail? How long does it take the sails to turn through 180 degrees? How long does it take the sails to turn through 180 degrees? That's part A. Then part B. What angle do the sails turn through? What angle do the sails turn through? In 30 seconds. In 30 seconds. Now, I don't know who is guiding there. I think I should put that question here before somebody can guide us through that. Read for us the question here. Question 3 was?
The sails of a windmill complete one full turn in every 40 seconds.
Of a windmill, complete
One full turn
complete one full turn
in every 40
in every 40
seconds.
seconds. Then,
How long does it take the sails to turn through 180 degrees?
how long does it take
The sails
the sails
to turn through
to turn through 180 degrees? How do we get that to be done? Guidance. Have you discussed? You can discuss over 2 minutes. Or somebody's ready? Yes, patience. How do we arrive at that solution? You can come and discuss it over. Part B, somebody should be preparing.
My question is, the cells of a windmill complete 1 full turn in every 40 seconds. How long does it take the cells to turn through 180 degrees? So it means you have to find the seconds, because they are asking for how long. So these are the degrees. And this one are seconds. Okay, if it turns 360 degrees,
Why 360?
because it's 1 full turn
Yeah.
in 40 seconds, then how about 1 degree? It will be 1 out of 40 seconds. Then they're asking for 180 degrees. So 180 degrees will be 1 out of 40 times 180. And these are the seconds. So we divide, we cancel. 4 divided by 2, we get 2. 18 divided by 2, we get 9. So we will be having 1 times 9 out of 2. 9 divided by 2, you get 4.5 seconds.
Is she smart and correct? She's not smart or she's smart? Grace, why are you raising up the hand?
So I also have
Another view. Okay, present your view and you made a mistake. Come and correct. Or you want her to present hers first?
let us present that.
First present yours. Yes, keep time because we have little time. I think you present it from here. Shall capture this later. And present it there.
Okay. Since they're saying that the windmill completes a full turn, and we know very well that a full turn is
You can write from here.
full turn, that's 360 degrees. So if they say that the windmill completes a full turn in every 40 seconds, so meaning that windmill completes 360 degrees in 40 seconds. So what of if the windmill only takes just like 1 degree? How many seconds will it take? So we shall find for 1 degree.
40 out of
So it will be 40 out of
60 degrees.
360. And those are seconds. And then you will find for
180 degrees.
yeah, for 180. So the other way around is like, how does the windmill take to turn through 180 degrees? So meaning 180 degrees is their half of 360 degrees. So if their half of 360 degrees is 180 degrees, so you will find their half of 40 seconds, that will be 20 seconds. But then continuing with this method, you have 180 degrees, which will give 180 times 40 out of 360. All these are in seconds. By 4. 36 divided by 4. 36 divided by 4.
Divide by 4.
9.
9.
So 9. 18 divided by 4. 18 divided by 9. 2. You get 2, so this will be 20. So 180 degrees. We will take 20 seconds.
Yeah. I think that's pretty good. That's the mistake you made. You have essay or part B? Part B. Yeah. You only forgot, okay. You only forgot what? You forgot to say?
Minus 360.
Times 360.
Yeah, that's what I forgot.
You forgot that. Then 180 would be equivalent to
360 out of
360. Did you?
sorry.
That means you had to have
40.
40 out of 360 seconds. Then you'd have 40 out of 360 times 180, not so? Seconds, which right away gave you what? 20 from Grace's approach, gave us 20. Yeah, that's very good. That's very, very good. Okay, Precious, once take on, read that part B first. Read as she comes.
What angle do the cells?
What angle? Do what?
The cells turn sales.
The cells turn
In
through
30 seconds.
in 30 seconds. Take on very fast. We have only 1 minute and a half.
Alright, now at least in the question we are given the seconds that are taken in a full turn. So we shall say 40 seconds are taken by a full turn, which is the same as 360 degrees. Then what of 1 second? It's taken by 360 degrees out of 40 seconds. So now the question is asking what angle do the cells turn through in 30 seconds. So 30 seconds are taken by 360 degrees out of 40 seconds times 30 seconds. Seconds and seconds. Then 4 by 4, 1 by 4, 9. Then 9 times 30, which is equals to 27, plus this 0, which is here. So the answer will be 270.
Yeah, that's great. Thank you very much. Do you doubt? No. Now, that throws us, but I would that you use words 40 seconds turn through 360. 1 second will turn through. Use complete words. Now let us go to bearing and its notation. And I want you to be so keen here. Bearing and its notation. Now we saw that all angles we were turning through both clockwise and anti-clockwise, and our north was the what? The 0. Now listen very attentively. You need to listen. Yeah, because it would be better. Now, in bearing is just a location of another point when you only move from north clockwise sense. I don't know if somebody understanding that when the turn is made clockwise from north, that angle measured, we are going to call it a bearing. The angle is called a bearing only when it has been measured from north or from 0, and in which direction? Clockwise. When you speak this way and clockwise, you are not speaking of bearing, you are speaking of turns. You are turning. But when you now turn through clockwise direction from north, then that is what? Bearing. You see? Yeah? But assuming you wanted to locate another point B here, not so? And if this was A, clear? Then you'd have to join these two, not so? We need a what? A ruler. Let me use this one, but make sure you use a suitable ruler. Now when you do, you need to listen very, because we are understanding what we mean by bearing, and it's not a. Now, I hope you see that. Now, if I wanted to locate this point B from A, then I have to speak of the angle from the north, like that, not so?
Yes.
That means I would have that. That's now the bearing of B from A. And I would now put my protractor there. Now you need to also understand in bearings how we are going to measure angles using a what? A protractor. Remember that 0 is on this axis here. 0 is here. That means 180 for half turn will reach here. Are you listening? That means reading an angle between 0 and 180. Between 0 and 180, the protractor must be made vertical like this. Then if you want to read an angle beyond 180, maybe 200 what? 22. Clear? Now, for any angle between 0 and 180, the protractor is like this, and use which scale? The outer scale. But then if you wanted to read 22, you'd now turn the protractor this way, because you have ended here counting. Now you bring it back here and you continue. Now you subtract from 180 and you see the balance. That's what you read still on the outer scale. That means our bearings are only going to use the outer scale here. 222 minus 180, you get 40 what? 42. That means our 222, you just read 42 from here. That would be here, and that will be where the other point will be located. Now I want you to listen. Very, very attentively. We've said angles are measured from north going this way, and that angle that you have measured is called a bearing. Now, I think you've captured that heading, bearing, and its notation. Now, according to you, what is a bearing? Yes, Grace seems to think aloud.
A bearing is a location of a place from the north clockwise.
Okay. Okay. That's pretty good. You want to say it, Patience? You want to say something? Okay. But, okay, in simple terms, that's very, very correct. But we can add more. You can have as many definitions as possible. Or the number of degrees through which an angle is measured from north to the line that is drawn from the center to a certain point. The bearing is the number of degrees. I think you see that. The number of degrees that has been measured from north to the line to the line which is through the center of the compass to a point. To the line which is through the center of the compass to a point. Or she said it is the location of one place by measuring the angle from the north. Not so? That's very, very brief and simple. Now, listen. Now, notation here we mean how do we write bearings. Now, that means the next discussion is on notation. Notation of bearing. Are you capturing that? Notation of bearing. It is a way of representing bearing. Now, bearing has two notations. We have what we call a north-south notation. Clear? And we have what we call three-digit. There you are. Now, we shall write how we got the example here. To understand what we mean, write the bearings for the following points. Points from A. Now you need to really listen, because we are now about to go to scale drawing. That we are saying that bearing can be represented by how many notations? Two notations. Now here is your north or the zero, not so? Or the zero. This is our point A. Now I'm drawing some other points here that can be located from A. And this is east, this is west, this is south. Now if I'm locating point B, point C, point D, we want now to write location of each point in terms of the two types of notations, and we see how do you really represent that. How do you really represent that? Now we are starting with the location of point B from A. Bearing of B from of B from A. Now look at that. I'm just putting their angles to just use them for demonstration purposes, and I'm also putting this angle for demonstration purposes, and I'll also put this angle. To me, this one as 45. Now listen. How do we speak the location of B? See, Grace had a suggestion. How do we speak? Speak and listen. We are using two types of notations. I want the north-south notation. Okay, to summarize everything well, here I can create a small table from then north, south notation, then three-digit notation. You need to understand this class. I pray that you understand from A to B, then A to C, and A to D. Okay, you said you are ready?
Yes, for the
3-digit format for B. How would we read the bearing?
050.
That will be read as 050. That's all? Yeah, that's accurate. Yeah. What of the north-south notation? Just mention between north and east. That's north 50 degrees east. Yeah, there you are. That means there should not be 3 digits. That's all? There you are. What? Yes, your excuse.
So meaning you have to use the main points of the compass when it comes to the north, south.
Say it again.
You have to use the main points of the compass.
The main points of the compass, you mean?
East, south, west.
Exactly. You only use those 4. It should be clockwise only to qualify to be bear. If it's not clockwise, it isn't bearing. You see? Now, what of this 3-digit format? Remember that you have to count from here. No? What angle is that? Yes. I want it from Precious. One hand is ready. You tell us how you calculated it. Yes, Grace, go ahead. You seem to be very, very ready. What is that?
120 degrees.
120? How?
Because from north to east, that's 90.
90.
Then east to south, that's still
Here.
90. Yes.
Here is which angle?
Okay, I'm first of all explaining east to south.
Explain.
That is 90.
This is 90.
But then they've given us 60 degrees, so you subtract 90.
The vertical angle from 90.
Yeah.
To get what? To get
To get
30. 90 minus 60, you get 30. Then you are adding it to,
90.
you are saying it's now 120. Now what of the north-south notation?
It's north.
Oh, there you are.
Okay.
South. And me, I've helped you there. Now when you are here, it will be southeast. But the angle should not, you should not use this horizontal one, you use between south and the line. Because you can be tempted, you find the angle is here, and you'd think you'd say south is 30 east, no? You have to find this vertical, and if you are speaking in terms of north-south notation, you must use the angle between the vertical and the line. Understand that? Vertical and?
But excuse me,
You are very much excused.
how come there on A to C you've not started from clockwise? You've not followed the clockwise movement.
I have followed the clockwise for 3-digit angle, not so?
North, south,
Now here this one here. Here this one. Now a bearing is the number of degrees, the angle. Did you hear that? The angle. This is the this is another format. The actual angle is what we measure from. But the other format, you locate it between the line and the vertical and the line. And it should not be 3 digits, it must be 2. There you are. Out of this one, 3-digit notation for point D? 200? Are you very, very sure? From here up to this. Which total angle is that? 220? 225. What of the north-south notation here? Think through.
South 45 degrees, west
Which angle have you used?
45, which is next to south.
Use this one. You don't use? Now, let me add a point here. You don't want to scatter my diagram there. Let's understand this notation very, very perfect, right? You see. Now, if we had there and I had here an angle called 40, there you are, and I'm calling this point point because E is here, F. What is the location of F? A to F. You see? You must understand. Let me see A to F. Let me see hands. 3-digit format first.
And 310 degrees.
310. Everyone, you get that correct? You added from here until here. Okay? Or you say the 360 minus here. Any format of your addition is okay. But you must also understand that the angles at these points are these, not so? Here there is one what? 80, here there is? That means you can get this plus this, direct. Oh. Then this format, north-south format? North? There you are. You use the angle between the vertical and the line. The vertical and the... There you are. I'm now giving you questions here. Okay, since you are the presenters, somebody is still questioning the 50. Come and explain that 50 very well in 2 minutes only, and I give you these things. And I give you these numbers. Come and explain in 2 minutes. You can keep time. We have very little.
Okay, getting the 50 will simply subtract it. Because we base on this angle from the north or the angle here from the south. This angle that next to these points. So here we based on this angle and it is important to us. So northwest, this is 90 degrees. Yeah, it's not meant to be anti-clockwise, but then we are finding for this so that we can answer this. Because this is clockwise too, not anti-clockwise. So that's how we got 50 degrees. Subtracting 90 minus 40 degrees to get 50. Still okay.
You are now clear. Now, she's satisfied, like as if ate food, not so. You have given her knowledge food. Now, write question 1. The bearing of B from A, the bearing of B from A is 135 degrees. What is the bearing of A from B? Now, we would like that one clearly. How do we, this one we are not drawing them to scale, they are just sketches, not so? The bearing of who from who is who?
The bearing of B from A is 135 degrees.
That the bearing of B from A. That means you estimate where will 135 be? 135, that is the north, which is 0, 0, 90, 180. Then 135 will be between here. That means, yes, then that will, now where you reach, ensure you draw there 90 what? A compass also draw there. That's the north. Which one is located from the other by 135?
B from A.
From A. From A. Now, how shall we locate? That means we have to break down into smaller angles. Which angle is this? Now we have to break down into angles so that we can locate some angles from there.
45.
45.
Yeah.
45. Now, there are very many ways of arriving at it. If this is 45, this also,
45.
we shall look at angles, but your knowledge of alternating angles comes into play also. This angle alternates with that. Therefore, if you are to look at that, what is that bearing? Measuring from here. It is? Because from here, this is 270 on this line.
Yes.
Plus 45.
I think it's
315. That means 315 degrees from B. Clear? You have to, you can, because somebody can think of if this is 135, can alternate it with the whole of this as also 130, but it's better to break into smaller angles so that you compare alternating angles. Okay. Now I want to give you the last one, and we turn it to scale what? Scale drawings. Yeah, let me give you. Patience, have you captured it? Correct? You are set, not so? P is on a bearing of north 40 degrees west from Q. P is on a bearing of north 40 degrees west from Q. What is the bearing of Q from P? Yeah, now I want guidance. Guidance, or simply come and use 2 minutes. Oh, you guide me. Okay. Yes, how can we locate northwest 40? How? Yes? Draw where? A line is where?
between north and west.
Between north and west. Here? Yes, north and west.
The upper angle will be 40 degrees.
So the upper angle will be 40, not so?
Yes.
Oh, that is the north 40 west. Then, what is this angle?
40 degrees.
Alternating angles is very important in this bearing, not so? Which point is this? Who is here?
It's Q.
This is a Q, this is?
P.
Read that question, what did it say?
P is on a bearing of north 40 degrees.
From
Q.
Then they want?
What is the bearing of P? I mean Q from P.
Now me I want two answers, two notations. Bearing of P. Of what? Of
Q.
of Q. When you are from what? From P. Now I want two notation is here. One answer in the 3-digit notation.
It's 140 degrees.
140 degrees. Then north south.
South 40 degrees. East.
South 40 degrees.
East.
This one here. The other one you just added this.
Yes.
Are you doubting this too? No, you don't doubt at all. Also don't doubt like you.
But teacher, if this bearings don't clockwise, then why is it that when we are using that notation of south, not south, we go again anti-clockwise?
Until now there are only two things here. You either start with the north or you start with. It's called the north-south notation because you are measuring from the north or the south. You are considering either from this line or this what? If you look at the south line, you go like this. Or you look at the, if you are in this part, you look at the north line. That's why you north-south. It's not east-west notation. So, now, let us leave that party of called what? We are now on bearing to scale, bearings on scale, bearings on scale. Now, must be very attentive, very attentive. Now, listen. We have left this notation things. Now we are on the bearings to scale drawing. I want you to be very attentive here. Bearing to scale drawing. Now I will first want to talk about what is a what? A scale. What is a scale? So, now a scale is a representation of the actual distance on a map. The representation of the actual distance on a map. Now, that if the actual distance, like from Kampala to Mukono, say is 50 kilometers, of course you can't draw 50 kilometers. Which map will you be able to draw that you will have 50 kilometers from Mukono to Kampala? Definitely you will not have that map. Now what we do, we simply represent that 50 in terms of what can be put on a map. Like on a map, you can use your ruler and draw centimeters, not so? Centimeters can be drawn or millimeters, but you can't draw a kilometer. Therefore, you would let something small in terms of centimeters represent a big thing in terms of kilometers. See? Now listen. A scale can be written that 1 centimeter represents now how many? 50 kilometers, not so? Now listen, we can write a scale in words, or we can write a scale as a ratio. 1 to 50 what? Kilometers. Now sometimes, you need to listen very attentively, sometimes scales can be written, you can find a scale written 1 to 50, 1 to 5 what? 5 what? Now I want to ask you how many kilometers, 1 kilometer is how many centimeters?
1,000.
Are you sure?
No, 10.
King
100.
100,000. 100,000. Now listen very attentively. We are now explaining the scale. You see, we are saying a scale you can write in words. 1 centimeter represents 50. Or you can say it in terms of ratios having units. When you don't want to show units, you will write the scale in similar units. If a scale, because you'll normally find in your maps written 1 or 2, those who are doing geography, you'll find it written 1 or 2, 5 million. That means the unit is the same. For you to have a ratio, ratios normally occur in the same units. You see that? That means if you are to represent it as a ratio, then the units must be the same, centimeter and centimeters. But if you want to show units there, then you don't have to represent as. When you use a ratio form, then you make sure they have the same units, because ratios can't have different what? Units. I hope that's very, very got clearly. Now, I want to switch on now to give you questions, and we do 2 questions in. Let me read for you this number and you write. Are you ready? You're very, very ready. The bearing of C from A, the bearing of C from A and B, the bearing of C from A and B is 190 degrees and 250 degrees respectively. Is 190 degrees and 150 degrees respectively. If B is 40 kilometers from A, if B is 40 kilometers from A, on a bearing of 150 degrees, on a bearing of 150 degrees, find by scale drawing, the distance of C from Roman 1A, the distance of C from A, then Roman 2, B. Now, you see that question will need us to establish a scale, not so? The question has not given us a scale. Which suitable scale would we choose to shorten those kilometers? Which, how many, 1 centimeter would stand for how many kilometers now? Are you sure? Which value could we divide by 4 to reduce it?
10.
Could we use 5 or 10? 10. Won't it be small? 5 would create 8. Would your book accommodate 8 centimeters? 10 is better? 8. Let us first sketch. Read it together and we see. The bearing of who from who?
Of C from A. B is 190 degrees.
The bearing of?
C from A.
C from A. C from A is what?
190.
Where will 190 be on a sketch?
This side of south.
This side of a sketch is very important. Okay, let me start here. Our sketch here. Roughly, you are saying 190 will be?
This side
would be here. Roughly here. Who is located at this point?
C.
Point C. Okay, point C. Now it's better to use a graph book or a graph paper, because drawing these vertical lines would be a bit challenging. It means better use a graph paper to handle bearings. Okay, continue.
And 150.
Who is this? This is A? This is?
C.
C. What is that? This is 100? 90 degrees. Okay.
And then 150 degrees from B.
Where is it?
C from B is 150 degrees.
C from B is 150. That's a bit. Where is B?
Shall we put that in there?
Where?
The other side. Reason being 150 will come to that.
The distance given is between who and who?
It's between B and A.
B and A is what?
40 kilometers.
40 kilometers. Between B and A is 40. Then C is how many from B? That 150 is for what?
C from B.
C from B. C from B is 150. Out of B from C first. C from B is what?
Teacher, here is saying the bearing of C from A and
from B
is 190 and
150.
150 respectively.
Let us first
250, not 150.
150 is 150. Now look here. Well, let us first trace the location of who? Of C and B. Now, who is 150 from the other?
A.
B is 150 from C.
This B is 40 kilometers from the bearing of 150.
But it says the bearing of C from B is 250. 250 would be where? Of C from B is. Let me first work out that. 250 would be here.
Yes.
Of C from B is here, C is here. Not so. Now, if this is 250, what is this? And this is 270. That would be 20 when this one is, and this one is, if this is 20, 70. Now, that means I'm going to locate at 70, to locate point what? B from C. There you are. 70 roughly on my sketch is somewhere here. You agree? This is what? 70, not so. And I will have found my point called B.
But then, what was the distance from here?
To which point?
The distance between...
They have given me this one. They gave me this one also. Yeah. This is what, 40? Now there is a problem there. Not so? There is a problem there. Not so?
Teacher, meaning you have to first draw a sketch.
You have to first draw the sketch, yeah. Yeah. But now we have a task to locate, we have a task to locate where there is C and where there is where there is a C. How do we achieve that, class? How do we arrive at those locations?
Teacher, you can use your divider to measure the distance from C. I mean, the distance of C from here. You use a divider. Then you put on your ruler and you see the distance, maybe in centimeters, and you convert to kilometers, depending on your skill.
After finding the scale, you construct another.
So what's the scale of that?
The scale, we can reduce that 40 using which scale is that? 5 or 10? And that means 1 centimeter will represent 5 kilometers. But you have a task there of locating. If you convert this, how will you locate this, each location from here? Because you don't have this distance, you need it and also need that. Yes?
Finding the distance between the points. You will have to use the scale. 1 centimeter represents 5 kilometers.
But the problem is drawing them accurately. Where shall we locate them?
Just give them distance.
Where shall we locate them? Where shall you locate them? That means we are going to add another distance there to simplify life. Yeah. That means add the distance there. The distance between B and C, the distance between B and C is 60 kilometers. Okay, now go to your, that means you'll have this as 60 kilometers, then go to your scale. What is our scale there that we have chosen to reduce? Represent 5 kilometers. Then go ahead, 5 or 10? 5 would be better. Therefore, 40 kilometers would be equivalent to 40 out of 5 centi, giving us 8 centimeters. Then you go to 60 kilometers.
60
out of 5 would give you 12 centimeters. Okay, that means on an accurate diagram, what will you do? I encourage you use a graph paper, because a graph paper you will just draw, the boxes are already there. It is easier. Unless you are caught where you don't have the graph paper. Let us try to draw this. Others you will do them in your revision, since now you now locate those directions. Is that fine? Yeah, now me, I'm using my blackboard here, my whiteboard rather. Which one are we first locating here? We are first locating who? First locating C. First locate C. That means our question there had a small problem. Does it mean so? Had a smaller problem. Yeah, keep time, because we have very. It will let us first trace point C. Point C. Point C. Now, since I'm using this, that means that I will have to make sure I'm using 90 accurately, since I don't have a graph north. This is my point what? Point C. I'm first locating which angle? 70 would be measured like this. That means that is 70. Are you together with my 70 there? No, sorry. Angles are measured how? Like this. Sorry. Mistakes are human, not so. 70, because we said we measure from north up to there, not so. That is the 70, and you make sure that is 70. Now you make sure that distance is how many centimeters? 12. Is 12 really? Would it fit on your ruler?
Yes. It's not that.
It's not that big? Yeah. Now when you locate 12, you can use your compass to locate it a bit accurately. The 12, locate it a bit accurately. That means go to your ruler and locate 12. Notice so? Yes. And locate 12. Locate 12. That means our 12 is right here. I hope we are together. Notice so? We are together. Then when you come here, you have to draw again a 90 degrees at this stage here, and 90 degrees degrees here. 90 degrees, this is the point. Yeah, this is point B. This is 6 centimeters, and that is the 70. Yes. Grace, is there a problem? Now we need to locate this. We need to locate point A. That means we can pick it from, if this is 190, hope all is well, not so? Yeah. Now let us do an example on the scale drawing. Just one example is enough, since you know how to read the angles. Now you can write this one. A plane flies from airport A. A plane flies from airport A on a bearing of 030 degrees to airport B, on a bearing of 030 degrees to airport B, which is located 80 kilometers from A. It then alters its course from B. It then alters its course from B so that it flies on a bearing of south 40 degrees, east, for 100 kilometers, to point C, Part A, by scale drawing, show the flight of the aeroplane. Then part B, find the distance and the bearing. Of C from A. Part C, if the aeroplane flies directly from A to C, at a speed of 25 kilometers per hour, find how long it takes to reach C. Yeah, I think we can go over that, then we close down the bearings. It has been quite long. Now we have to first sketch, not so? Now in the sketch, you help me and we follow the sketch together. We can have our sketch this side and the accurate drawing the other side. Can you guide me as we go through the sketch? The sketch. How are we sketching that? Whom do we locate first? Airport A. Not so. This is north. Where is B? Where is B?
B is
Up here.
130 degrees.
030. Oh, I need to push it down. Eh?
Yes.
Okay, 030. 030. This is north. 030. Where can I write 030? Where can I write the 30? I write here.
Yes.
30 degrees. What is the distance?
80 kilometers.
80 kilometers. That means flow like that. Then from there to where did it go?
From B, so that is
What's the bearing at TB?
40.
To see from B, it uses which bearing?
So 40 degrees is
This way.
this.
That is 40
degrees.
east.
Yes.
And that's the south. How many kilometers?
100 kilometers.
Kilometers, not so? Then make sure this line is shown that to be longer than this, because 100 is bigger than.
8.
Yeah, then here, that means this would be your. Now they are talking about point what?
C.
C, and they are talking about this one. That means I'm giving you a few minutes, you try to draw to scale. Which scale are we using? The question didn't give us the scale. 1 centimeter represents 20 kilometers. Then what of 80 kilometers would be?
80 out of
20, giving us 4 centimeters. 100 kilometers would be?
100 out of
Haven't you reduced very much?
no.
5? Huh? Or you have a very small book? Okay, can we now go to scale you handle? You can handle to scale. Okay, we can demonstrate to scale there together as we move. Now we are moving together, not so?
Yes.
That means keep for me time. Ensure this is 90. That means it's better you locate using a what? A protractor. And you do now know where 90 is really. And it's better now you will know that that's kind of 90 created here. 90. Which angle are we measuring? We are measuring 30. We said we measure? Yes. 30 is here. Then that means we indicate. I put my long ruler. Then not so. Then measure how many?
4 centimeters.
You now measure 4 centimeters on your ruler. Then you come and try to locate, not so? Where it is around there. And you also go there, put a horizontal so that you can draw a vertical. Then we have to now get our vertical there by using 90 here. That's why I say draw on a graph paper, because a graph paper you don't need now this. Yeah, because it has vertical lines already drawn. That means again have that. This again in north, not so?
Yes.
Then this how many centimeters? 4 centimeters. Locate this as 60 degrees. 30. Yeah, 30, sorry. There, what are you locating? 40. And the 40 must be, I hope you are seeing how the 40 is labeled now in a scale. That means the outer scale will be at 140. Yes. Then there you are. And we now have to measure how many centimeters?
5 centimeters.
Yeah, 5 centimeters. That means you must go on your ruler and keep sure that it's 5. And that now you draw the horizontal here. And now you draw a what? A 90, the compass direction around here. This I'm only doing this because I don't have a graph paper. This is north. This is 10 centimeters. 5. This is point B, point C. Try to just reduce this line. Just reduce it. Then put dotted lines between here and here so that we can read the my ruler is moving, sorry. Okay, now that seals us there. I think we understand that, not so? What does the first question say?
By scale drawing, show the flight of
which we have shown. Part B.
Find the distance and the bearing of C from A.
Of C from A. C from A. That means get a set divider of C. Then you take this one to your ruler and read in centimeters. Then you must multiply by 20 to convert to kilometers. Then the next question.
And also
The bearing of C from A. Where do we stand? C from A. We stand at A. Now we measure from north to this line. We can state in 3-digit notation. This one is around, mine is at 96 degrees. If you get 96 bearing of what? See from A is now 0.96. You have to add a 0. Now the last question. What does the last question say?
If the aeroplane flies directly from A to C at a speed of 25 kilometers per hour,
Find how long it takes to reach C.
How do you get time? Is distance? Distance out of? Speed. Our distance that we got, that you converted, you got in centimeters and multiplied by 20, you'll divide by that speed to get time in hours. Time in hours. Now it has been a long lesson, but we've gone through many things. Bearing, you know, now we can read compass directions, make turns, not so? Then locate, read the bearings in its two notations, and to scale drawing you can also draw, not so? Yeah, now let me give you this activity of integration, and we shall meet in the next topic. Thank you for enduring a long lesson. Let me give you this activity of integration, and we go. Ajok is in Kampala City. Ajok is in Kampala City and has been told to use a car. And has been told to use a car to move to Lila Town, and has been told to use a car to move to Lila Town. She has never gone to Lila. She has never gone to Lila. She has been given a map of Uganda showing routes. She has been given a map of Uganda showing the routes through which she can access Lila Town. Routes through which she can access Lila Town. Then paragraph. Ajok wants to use the short distance from Kampala to Lila. Ajok wants to use the shortest distance from Kampala to Lila. Explain how Ajok can determine the shortest distance. Using the map given to her. Using the map given to her. Is it possible for Ajok to use the shortest distance she has determined? Is it possible for Ajok to use the shortest distance she has determined? Explain your answer. Explain your answer. We shall meet there, from there in the next. Bye.